Interesting. Because numbers are going to be removed, so... Huh. So it should be 1 to the size of even, because even will be our base one that we're using, because as we take an even number, then we take an odd number. Although when we switch, it becomes the other way around, so that's true too. So this tracks the number of pockets used. This is tracking the switch between 11 and 7. And this is tracking the block progression, so 1 to 18. Then we need another one to track the block that we're on, so I4. But we're not going to iterate that one. So now we need to say if I4 modulus 2 equals 0. Because what we have to do now is we have to say else so if block is even, if block is odd, so 1 to evens dot size, 1 to odds dot size. Alright, so now we have to do this, which is we have to account for the 7 to 11 or 11 to 7 thing. So if I2 is less than equal to or less than, that should be less than or equal to 11. Then we do that. Else if I2 is greater than 11. We also want to then check after doing that if I2 equals 18. Because when it equals 18, we want to set it back to 1. We'll do this as greater than or equal to 18, because what will happen is we'll have a we'll have that there for a check just in case. And then I2 else I2 plus equals 1. So increment I2 if I2 is less than 18. we'll do equals equals because we actually won't have to worry about that because it'll do it only if increment only if it's not 18, and if it is 18, it's not going to increment. So, so we don't need to check for if it's greater. Though we probably should check just for. I'll leave it there, but we'll it'll just be there as a debug measure in case it ever goes above 18 for whatever reason. Okay. This is really going to be complicated. So, if I2 is equal to or less than 11, so now we have this. Next we need to this is actually gonna happen in both of these ifs up here, because we're working on either evens or odds, and that depends on what block we're in. So taking something as simple as picking numbers out of 2 jars and complicating it to all hell and back, courtesy of the modern age. I'm going to do this to reformat it properly. Alright, so then we also want to take this block of ifs and apply, copy them down here because we'll be using them in there as well. Okay, so if we're on an even block, then we're using the evens. So we want to get the value that we're using based on this here, because we don't want to check to see if we're using again an even or odd block again, because then we'd have to, if this wasn't in here, we'd have to do that to find out which value to pull from, use IRN to pull from, which vector. And yes, it sounds insanely complicated, but it should be less complicated as we get this done. So now what we want to do is we want to find the value that we've picked at random from IRAN. So we get value picked we'll use for that, vpicked. So vpicked equals evens dot at IRAND -1, obviously, because we're doing a 0 to size index instead of 0 to size -1, or 1 to size instead of 0 to size -1 on that. So we need to do a -1 on the IRAND to make sure it's 0 indexed. So get the randomly chosen value. And now we need to take this and say, so vpicked, and then we need to say, or let's use E and O, even picked and O picked, because we can use these both in either case. Because then what we need to do is we need to find out the value of the odd that we're going to be using as well. So vpicked and then O picked equals vpicked +1. Get the odd number pair for the chosen even. Alright, so we've got our E and O picks here. It should be E, not V now. So we got our even and our odd picked numbers. So now we need even more stuff. Let's see, we need some more vectors. Well, the problem is that we need a vector for every pocket or every block that we have. So up here we need to do a vector called blocks. or string rather. And what we'll do is we'll take the randomly chosen stuff, put it into blocks. The blocks. So actually, we want to do a double vector. A vector string. So essentially, we're creating a vector of string objects. Or a vector of string objects. So we'll have an infinite number of elements per element. So kind of a paradox, if you will, or a never-ending hallway kind of thing. So for I equals 0, I is less than pockets divided by 18, I plus plus, and while that conditional statement is true, we want to add a new element to that vector to blocks. Let's build it and make sure that actually works here. Blocks has a previous declaration. Oh, as an int. We'll say RT blocks then. Roulette table blocks for roulette table order. Alright, let's try it again. Events was not declared in this scope. Oh, should be evens. Derp. Sweet, that worked. Awesome. Awesome. No, wait. Here we go. Never mind. No, it didn't. There's an error. So RT blocks pushback, vector, string, expected primary expression before token. So let's create a vector of strings. And then we'll just put v strings in here. And that should get rid of that problem. Yes, and yes it did. Okay, good. So now so I3, which is the current block, I2, and that's just nothing. So, and then the total number of pockets used, which is I. Actually, that would be evens and odds. Or rather, no. E picked and O picked. This is just to say, okay, this is what these values are used for. You don't have to always do this verbose of a thing, but I'm going to do it with this one just because it is as complicated as hell, and I'll need to probably refer back to this occasionally. Okay, so we got our E picked and O picked. Now we want to take these values and put them into their proper blocks. So, remember, we're doing I3 for blocks. So if I3, or we should do a switch on I3. That'd be much easier than an if, because then we won't have to do all the if then else cases and have all the tabs and everything, or the curly braces. We can just do it this way. So case 1, so block 1. Case 2, block 2. Case 3. Well, see, the problem though here is that this can't work because it has to be it has to account for an infinite number of blocks because we're dealing with a vector. So we actually want to do another for loop here. I4. I knew we used I4 for some reason. Let's take I4 out of here. We don't actually need it. And take I3 out there because we don't need to put it there. Not sure what I3 is going to be for originally, but do not need it. So if I3, I3. For I3, or rather for I4 equals 0. I4 is less than I3. Or less than or equal, well, yeah, less than. Because I3 is 1 indexed and I4 is 0, so I4 plus plus. So if I4 equals I3, or rather it should be RT blocks dot size. So if the block that we've iterated to is the current block that we're working with, then we add add the even to it. So RT blocks dot at I4 dot at or dot push back, and then we're going to do the letter, which is either going to be black or that's another thing, we need to track that, don't we? Alright, so we actually need to do an I5. And I3 does need to be iterated. Alright, so if I4, this is going to be I5. And I3 is now for that. So we'll have to change the code down. We'll have to recopy the code anyway, so let's get rid of this. Or at least the second part. Alright, so if I2 equals 1, and so if we're in the 11 section here, what was the so So as evens are black, odds are red in the long ranges. Yeah. And then it switches to evens being red and odds being black in the short. So man, this is really complicated. Alright, so this is a long section, so the first one is going to be black. Or rather, if it's even, it's black. That's right. Not if it's 1 or 2, but if it's even, it's black. So actually, we don't even need that. Or no, wait, we also need to track if it's even or odd for the value chosen, right? This is just if the block is even, not if the value is even. This is, yeah, we need to do more checking than this. It's got to be way more complicated because the first element has to be even, then the next one has to be odd. So that check has to go here. So if, so I choose the current color to use. So we need to go even more. It needs to be an I6. Damn. Because I5 has to be here. And it has to be iterated as well. So this needs to be down here if I6, or I4. So this should be I. Because then I4 should be I4. essentially what I want to do is I want to go backwards on these with the i's. So each next level is taken down by one value for I. So I5 is the highest level of breakdown by block. The next lowest is by the value added, so I4. The next lowest after that is by the number of the pocket, which is I3. I2 is by the color to use for that pocket, and then I1 is number of pockets used. So these two may not be in the correct order, but the rest are. So I5, I6, 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 I6 equals I5. So I5 is not iterated, but I4 is. Alright, so if I4 equals 1, then it's an even number. Else if I4 equals 2, that's an odd number to use, and we want to reset I4 to 1. At the end of that one, so we can restart it again and use do that. So let's go ahead and realign the tabbing here. Alright, so now we've picked that, and we're in the evens, so we want to say now we need to check for I2, like what we're doing. If I2 equals 1, or rather, well, let's see, we actually can do that without that, because we've determined we're in the long section, and we've determined that this value is supposed to be an even. So we can just say, okay, this is going to be red. So we don't need to track that then, the current color to use. Although we'll leave the I2 there in case I find out later that I actually do. Was it red or black? Evens are black, so it should be black first. Alright, so what we then do is we say RT blocks dot at I6 dot push back, and then we say B, then plus E picked. Now the next problem is how the hell do we determine the adjacent block value? So we have, let's go with this, I have this 6 block thing drawn here, so we're in block 1, we add a value, we have to add a value to block 4, so how do we determine how to get there? So I guess what we can do is we could take half of the total number of blocks and add it to the current number. So in other words, for example, we have, let's say we're in block 2, we add a value, we have to go to block 5 to add the pair, so we say, okay, we have a total of 6 blocks, divide that in half, that leaves us with 3. So 3 plus 2 equals 5, and so the block we want to add into is block 5. And that also works for pretty much everything. Now if we're on the second half of blocks, so that's the thing now. If we're on block 4, we actually want to subtract. Well, technically no, because by the time we reach the first half, the end of the first half of blocks, we've actually added everything else in. So we don't have to worry about that. Because the reason is because we're adding 2 values at once. We're adding one value to the current block and the value to the block on the other side of the table. So by the time we add all the values in up to the last block on the first half of blocks, we'll have added in the blocks all the values, all the pockets on in the blocks on the other side too. So that actually works out fine. Alright, so find the value for the adjacent block. So we got blocks up here. We need to add another int. Call it a block, adjacent block. So to find this now, we take the number of blocks, which is blocks, rt blocks.size. So a block equals rt blocks.size divided by 2 plus I6. So find half the number of blocks, then add it to the current block. An example: blocks equals, or t blocks, t number of blocks equals 6, half equals 3, value added to block 2, adjacent block is 5, 2 plus 3. So now what we do is we go rt blocks dot at a block minus 1 dot add, or dot pushback red plus opict. Now remove both values from respective vectors. So evens dot erase evens dot begin plus IRAND. Now the problem is here is we have to figure out what value the opict value is in, or what element the opict value is in, so we can erase it. So for I7 equals 0, I7 less than odds dot so if odds dot at I7 equals opict then odds dot erase odds dot begin plus I7. That should be an IRAND minus 1, by the way. And we'll add I7 up here. Alright, so this huge complicated thing does what we want it to do now. So if I4 is 1, which means if it's even, if value to be added is even, in long section, so either way we're going to be doing a two thing here. Either we're going to be checking for I equals 0 and I equals 2 inside of this conditional statement, or we're going to be checking it like we are now. So either way you're going to have two of these, so I think we'll keep it this way. Even though it might make a little more sense to do it the other way, although maybe not. So now if I3 is greater than 11 in short section, we still do the same with everything else, just that's changed. Now, this also stays there as part of that. Now, essentially we just take all this and we copy paste it down here. And then we change how things work. So if value to be added is even, And essentially we just switch everything here. Switch everything around. Actually, this doesn't even need to be in this section. This can be outside of it. So we don't need to do it twice. Of course, this one needs to be the other way around, so I need to change it here. Alright. So now, on the long sides, we've determined that, yeah, odds are red and evens are black. On the short side, it's the other way around. So on this one, odds are red, evens are black. So we need to flip around the colors on this one. Oh no, wait, that was right. So if even on the long it's black, red, and on the short it's red, black. So black, red, red, black. Now for odds on the long, it's red, black, and then black, red. Okay, now I was right. Yeah, we do need to switch these. Red, black, and then black, red. Black, red, red, black. So black, red, red, black. Alright. And we have to do it both times because, again, like I said, we have to add the pair in for that. Now, what else? The other thing we need to do is once is check for if we're at the beginning of a block or not, to add the zeros in. So that's what was it, 3? 2? Number of pockets in current section. So it's 3. So if I3 equals 1, that's what we want to check for. So that'll be at the beginning of this. If I3 equals 1, and this becomes another else if. if I3 equals 1, or is 1, at the start of a block, add 0 pocket. So for this we just do essentially this part here. Let's actually create a string here, because again we have to account for how many blocks there are, and with each successive block we have another 0 added. So string B0. So where were we just working at? Here we go. Alright, so as we're going through now, we want to take B0 and we want to add to B0 a space, or add another 0. So essentially we just want to add itself to itself. I wonder if we could do that. Add a string to a string in that manner. Should be able to. I guess we'll find out. G plus B0. Then after we just want to turn B0 to itself here, to a 0. And so what will happen is that every time we go through the loop here, we'll add a 0 onto that, and so that will allow us to get the proper number of zeros for the proper block we're on. Let's add that up to technically we should add it here because one thing we have to do here though is remember, because we said that if a block is even, then we have to use an odd value first. So we have to say I4 equals 2 for this one, if a block is even. We'll actually set I4, oh no wait, it's I5, isn't it? That's what we're doing for blocks now. I5. Oh no, I4, yeah, because that's the... So I actually want to set I4 to 0 to start with. So we can check for if it's 0. So we can set it properly here. It's also very complicated. So 2. Since this is an even block, odd must start. So, and we take all this. All the way down to this other I4. Let's see how many. So it should be 1, 2. So 1, 2, 3. So it'll be the. I have no clue. Let me see. Okay. Starting from here then. God, this is so complicated. So, it has to be 1. There's a count up here, I believe, or there isn't. There should be. So count. Creating. Pocket order. Alright, so, now, once this for loop is done, B done equals true. I believe that's the one we want to use. Or we could just take this out entirely. Yeah, we don't even need this, actually. Now that I think about it. That while loop was there for some other purpose that we don't actually need for now. I'll leave the be done in though in case we use it somewhere else. So now what we have to do is let's see. If it equals 18, increment I2. I3 to 1. Then we need to increment I5. And we need to put that into, copy that into all the other places. Or no, wait, it should be up here. Too bad that reset isn't actually resetting it. Damn. Okay, reset. One, two. And there should be one more. Alright. So, let's go ahead and build this and see if it actually works or not. Don't even have to place any bets. I know there's going to be bugs. We'll have to see. So what's it not like about that? No matching operator? For what? Oh, and oh, damn. How the hell did I miss that? There's another face palm. Alright, let's go and rebuild it again. Well, it actually built. No errors. So, let's go ahead and run it and see what happens. We'll do 36. So now we need to print out the order